Okay, welcome to the session Climate and Circular Solutions Made in GREENTECH Valley. In this session, you will hear about a variety of different climate and circular solutions, as we have in the GREENTECH Valley a technology hotspot in that field. My name is Ines Güsser-Fachbach. I'm from the GREENTECH Valley cluster, and it's a pleasure for me to guide you today through this session. What's the plan for the next 75 minutes? First, Bernhard, Managing Director of the GREENTECH Valley cluster, will say something in general about the GREENTECH Valley. And in this context, we'll set the stage to the next presentations. And then Binder and Co., Siemens, Andritz, Hycenta, Best and Holcim will talk about their circular and climate solutions. It's possible to ask questions after each solution presentation. Just one or two small questions due to time reasons. So please, after every presentation, just raise your hand and then we can come with the microphone to you. And otherwise, if there are longer questions, of course, the speakers are happy to speak with you also after the session. Okay, so that's enough from the beginning. And I welcome Bernhard, Managing Director of the GREENTECH Valley cluster, to the stage.
Thank you so much, Ines. I will present you a few slides about the GREENTECH Valley. Why is it called GREENTECH Valley? And what benefit can you as a company out there have from these solutions? So, as mentioned already in the last session, Austria is the Europe-wide leader in eco-innovation exports. And this powerhouse is driven by the region in the south, the valley around Graz in Styria, Carinthia. It's regarded as world's #1 clean tech cluster by American venture capital networks, but also due to other rankings. So quite a good place to deep dive into innovation, which technologies are mainly researched, developed and produced here in this southern part of Austria. It's mainly about efficiency, industrial efficiency, net zero technologies, green heat, green electricity, mobility, including hydrogen, also for industrial use, circular solutions, building technologies, all driven by extended research. So it's more than 5% of the GDP that is done by research, more than 2,300 academic researchers in a very small areas condensed. More than 10% of the global green electricity is produced on technologies made in GREENTECH Valley. So one day a week, as mentioned before, is GREENTECH Valley Day in your green power outlet. This is mainly to the strengths of Andritz and the hydropowers they exported worldwide for the last 60 years, but also due to other solutions in fields of solar, wind and others. And these companies grow faster than the world market, so this is really a hotspot, ×3 within 10 years. When looking back, when looking forwards, we see the tripling of world markets until 2030 as well. The cluster organization partners 300 cluster companies, research organizations since 2005, and with private and public shareholders. This is really public-private approach. At the end of the day, our job are more than 30 industrial innovation projects to be kicked off and started, contacts, ideas established. How do you benefit from the GREENTECH Valley? Just follow the QR code and deliver these 600 technologies right to your company, to your facility, and to make this green transition with cutting-the-edge technologies. And if you are on the path towards climate neutrality as a company, this tool from the GREENTECH Valley, please follow also the QR code, available in English for free online, can help you on this green transformation. 50 seconds on how to use it. So it's inspirational ideas in 10 sectors, 10 persons in a company. So it's human resources, R&D, of course, purchase, production, but also finance and business models that you have to rethink when going towards climate neutrality. And this 100 cards give you a lot of inspiration to find your ideas and then at the end deliver your green transformation plan. Please find online the complete canvas. The cards, all of them are free to use, and they were produced from the GreenTech Valley with partners like Greta, GreenTech Academy Austria, and Denkstadt. So make use also of this free tool to deliver climate neutrality in your company as well, powered by technologies from the GreenTech Valley. Thank you so much.
Thank you, Bernhard. So as Bernhard mentioned, we are eco-innovation leader in the Valley, and there are several different technologies, and those technologies we want to explore at least a little bit today. And we will today hear about circular and as well climate solutions. And we will start with a circular solution from Binder & Co. And in that context, I welcome Thomas Wesian, who is product manager for sensor-based sorting and digitalization at Binder & Co. And with over 16 years of experience in optical sorting technologies, Thomas Wesian will today discuss how the transformation of construction waste into secondary raw materials can be managed. Thomas Wesian, thank you very much for being here. Please.
Yeah, thank you for the kind introduction. I think I have to lose any more words about my person. However, I would like to present the company I work for to you, Binder & Co., a company that provides products and solutions for the secondary and primary raw material industry. So we manufacture machines, we deliver them to our customers. We build also entire plants for various industries. So we have process knowledge, R&D knowledge, all in our house. I'd like to give you a very short overview about our portfolio, which is quite big. We have different sorts of crushing machines in our portfolio for crushing down big rocks into gravel or gravel into sand, for example. I'll have another example later on the next sheet. We also have all the machines for wet processing, for example, density separators, washing machines, hydrocyclones, everything you need for process water from some sort of installation. We claim to be market leader, or one of the market leaders in the screening sector. So we, I would say, have a solution in terms of screening if you have an application out there for us. The Viczek screen is very famous and very known worldwide for very heavy or hard to screen materials. Another smaller topic is the thermal processing. We try bulk material of all kinds, which is used in different sectors of industries as well. And last but not least, sensor-based sorting, my sort of baby and heart here, and the one I'm talking about on the next two sheets is one of our core and main products as well, definitely the one with the highest innovation grade. We use that in glass recycling, for example. That's what we are known for. And to mention it one more time, we are not just a machine manufacturer, we also have the process knowledge of all kinds of processes. Let's look into the principal setup of a construction waste recycling plant. After the demolition process, you see that on the left picture down there, you need to crush bricks and pieces of concrete down to a certain grain size. You may screen it in different grain size fractions for further processing, and you then wash off the fines, the dust. You may have a density separator for separating for separating wood and insulation materials, for example. So you see the portfolio I presented before is all included and all from our house. At the end of such a process, mechanical treated process, we'll have sensor-based sorters, making the magic to produce a clean, pure, fraction of concrete and stones, and as a pure fraction of bricks, for example. Bricks can't stay in aggregates. That's the reason why we need sensor-based sorting based on color information to remove the bricks. How does optical or sensor-based sorting work in general? We have a camera or different sorts of camera, different technologies. They basically take pictures of every particle coming through the process. We have a light source on the other end, and with either a color information, color difference, or a difference in the material type that's more chemical or structure-based, or even in terms of different shapes, we can put these informations in different classifications, and eject a specific material, a specific colored type of material into a separate bin by using compressed air and fast-acting valves. All that happens within milliseconds, so there is quite performant software needed for that. On the most innovative and last technology we just launched, and we still develop in different branches here, but for the excavated soil processing, we found out that AI blocks within our software are very efficient in terms of detecting black asphalt from black stones, for example. So we have the possibility to eject black asphalt from a excavated soil input material, which wasn't possible before. How is that being done? Different edge structures and minimal color differences can be detected by AI codes, and so there we have the classification and can do the sorting. Yeah, that was my presentation on the technology. If you have any applications, any needs, feel free to meet us at our exhibition area as well, as we have a booth there. Thank you very much.
Thank you very much, Thomas Wesian. Are there any questions from the audience to Thomas Wesian? There's a microphone on. Okay, otherwise just take mine.
Thank you. What will be the first appliances and the first markets that you reach with that solution?
With sensor-based sorting?
With the last, the AI-powered
okay.
asphalt recovery, is it for big companies like Schwabl that they will use it, or others?
It's mainly recyclers, recyclers of construction waste or excavated soil waste. So that's actually the first industry we started with AI with. We also have it in metal recycling, for example. So we see useful applications there, but also in glass recycling. So that's definitely a promising technology. I know it's a big word, but we have solutions already in the market out there that prove that technology.
Okay. Okay, there's one other question, and then.
I'm just curious to know if it's possible to sort out slag from natural soil or natural stones. Can you sort that?
We have applications in the, let's say, slag industry. Until now, mainly to eject glass from slag. If there is a color difference, if there is a material difference, we definitely can do that. So it depends on the mixture of the input material and other components, how the material comes in there. But if there is a color information, I'm very certain we can find a solution there. Absolutely, yeah.
Okay, thank you very much. So I would say a big applause. And we stay with the topic of circular solutions, but switch the company to Siemens. And in that context, I would like to welcome Herbert who will introduce us to the world's first digital plastics recycling plant based on MTB, the model type package. Herbert is head of Siemens sites in Graz and Klagenfurt, and additionally head of an innovative software development department at Siemens Digital Industries. Herbert, thank you for being with us here. The floor is yours.
Thank you. Hello and a warm welcome from my side. So let me present one of our actual sustainability projects in the area of plastic recycling. I want to start with a statement from our CEO, Roland Busch. He said, "We build technology with purpose. They are never an end in themselves. They help customers achieve more with less." So what's standing behind that message is that we do everything what's possible to support our customers in their activities to use their resources as efficient and sustainable as possible. So let us have a close view to the plastic market, the production and also the recycling of plastic. It's, I think, definitely unbelievable that we are producing around about 20 million tons of plastic waste in the European Union per year. And it's maybe much more surprising that just around about 33% of them is recycled at the moment. So going on in that direction means that in round about 2050, we will have more plastic in our oceans than fish. And I think it's a matter of fact that we have to do everything what's possible to stop this development and going in another direction. So that's also what the European Union thinks about, and therefore they decided in their circular economy package to boost the municipal waste recycling rate to 65% till 2030. That's a little bit more than 5 years, by the way. So, but the question is how you can achieve this goal. And our answer to that is based on innovation, on digitalization and industrialization, with the focus to turn, we can say, trash into treasure. And what's standing behind is that the plastic waste should be transferred in resources that you can use again and again. So, of course, it's not possible to work on such activities alone. We prefer, I would say, ecosystem approach, and for such an approach or such a strategy, you need also a professional partner in the area of the universities. And we analyzed the market, and we decided then to cooperate with the Montagne University in Lyon, because they had the right motivation, the right focus, the right features, and they fit it very perfect to our strategy. And after that, we realized, meanwhile, several projects in the area of sustainability. One of them you can see here is the Digital Waste Research Lab. It was officially opened last year in St. Michael, close to Lyon. It's already equipped with Siemens components, and the advantage there is that we can use the whole equipment for new funded projects, also for very interesting use cases, and that's, by the way, what we did in the last project. Just a small impression what's going on there, but based on the time, I think we should go on. So, having a closer look to the challenges of plastic sorting plants, there are a lot of, for instance, a lot of integration challenges, lack of standardization is one of the problems, and also an ongoing growing demand for adaptability. And we thought in our project how we can solve these problems based on a standard solution, and we found a so-called model type package, or MTP, and we decided in the latest, in the revised F project, to use this technology and show how it works in practice. So what MTP promises is 50% faster time to market, 70% reduction in engineering effort, and limitless flexibility. The idea behind is, we can say, a Lego approach for automation. But I think you know that the one thing is what the companies promise, and the other thing is how it works in practice. And so our idea is to check this in practice, and therefore We want to realize the first plastic recycling plant worldwide based on this MTP standard. We are doing this not alone. We cooperate, as I've mentioned before, with the Montana University, but also with some other companies like Meyer Recycling, Andritz, GREENTECH, and we are using sensors from AVK. It's a company located in Graz. So just to give you an impression about the complexity in the project and of how many things you have to take care of, for instance, the network design, the security features, the MTP features, I think you can imagine there's really a lot of work to make this project to a success. And we have a lot of work there, and you can see it here on the milestones, that we are close to the milestone first MTP integration in the lab. We should reach this milestone till end of July or beginning of August, and we are quite optimistic to fulfill this milestone. The good thing working in a big company like Siemens is that in working on a new technology, if you're lucky, you are not alone. Instead of that, you have support from other teams and also from other countries, and that's exactly also the situation here. But our approach is to push new technologies in this area in the market, driven from Styria and from Austria, but with a clear worldwide focus. So I'm not sure if this event takes place once more in next year or in 2 years, but if yes, and you invite me again, I can promise you I can give you a brief feedback about using this technology in practice and how it works in this project. Thanks a lot, and at the end I want to show you a small video. It's a brand new about the actual activities there in St. Michael on the location. Please start the video. Hopefully it works. So you can imagine not only software implementation is necessary, but also hard working. Just 1 second. Thank you.
Thank you very much. Are there any questions from the audience regarding this technology? Otherwise, he is for sure also outside available, so please,
if you have some questions.
If you have some questions, yes.
Thank you.
Okay, then thank you very much. Then now we switch a little bit the solution group, and we go to climate solutions. And Bernhard Buttinger already mentioned it. We can say that 1 day a week, the green electricity produced comes from Austria, and that's mainly to the Andritz. But Andritz also has the goal to become a leading global provider for green hydrogen, and that's the topic of the next presentation. And in that context, I would like to welcome the Peter Eisenköck, who is Vice President of Global Sales and Services and the founder of Andritz Green Hydrogen. He will share Andritz' vision of becoming a leading global provider for green hydrogen and renewable fuels production through their innovative P2X solutions. Peter Eisenköck, thank you very much for being here.
Yeah, thank you very much, Ines. So welcome to my presentation. Andritz Power-to-X Solutions, P2X. The power, the P stands for the renewables, then renewable electricity, and it goes to X, and X stands for green hydrogen or renewable fuels like e-methanol or ammonia. So really bringing the renewable energy into an energy carrier form. In our case, we talk about green hydrogen. We need carbon, CO2. We have to capture the carbon, the CO2, and then we can transfer it into a renewable fuel. So our vision is to become a leading global power-to-X solution provider for the green hydrogen and renewable fuel production. And our plants that we are designing, that we are building, are based on our own proprietary CO2 capture technology. We have here 2 pilot plants running in Austria and in Germany. Then alkaline water electrolysis, where we have a partnership with Hydrogen Pro to produce the green hydrogen. And then the PEM electrolysis, where we have a partnership with Bosch, and here we are building a pilot, a small container at the moment. And then the 4th point, methanol, methane, ammonia synthesis, and here we have partnerships with established licensors. Our offering basically covers everything from early stage support for project developers, for the feasibility study. So any engineering that is needed there, then the whole EPC, so the engineering, procurement, construction of the plant, and then over the life cycle, the digital solution for the plant and doing the operation and maintenance services based on that. So this is how our standardized modularized 100 megawatt green hydrogen block looks like. So it's a footprint of 140 meters times 60 meters, and with this 100 megawatt production plant, you can produce 20,000 cubic meters of hydrogen. And if we look on the picture, and do I have a pointer here? A little bit, you maybe can see. So we have the main building in the middle. The core basically is the electrolyzer stack, and 2 of them are then connected to the so-called phase separation unit to separate on the one side the hydrogen, on the other side the oxygen from the lye circulation, and behind then the DC supply unit, rectifiers, transformers. So each of or one of such electrolyzer system has 10 megawatt, times 10 is 100 megawatt. And then we have 2 auxiliary buildings, one here for the media, so we need a water preparation, we need cooling water, we need lye circulation, and on the other side the gas treatment. In this case it shows only for the hydrogen, but if there is a use for the oxygen, then of course the oxygen would be purified and compressed on this side of the building. Yeah, that's the basic layout as we are offering now. And maybe I should mention, if I talk about a 100 megawatt plant in green hydrogen, then the meaning is always this is 100 megawatt electricity going in. So it's a little bit special because normally you always talk about an output, but in the green hydrogen, typically everybody talks about the electricity going in. And this is a view inside of the electrolyzer building. So as we saw it before, it's on the right side the stacks, so really heavy, robust design. One of those stacks is 80 tons, 9 meters long, 2 meters diameter. And then on the other side, the phase separation unit, as I explained before. Coming now to our first references, we have in this market where Andritz is also a very young and new player. We have 2 projects. The one is the copper project in Finland, and the other one is Salzgitter in Germany. And I will show you 2 slides, one for each of them. So the first one is in Finland. We just finished the FEED engineering, the front-end engineering design package. and are currently waiting for the permitting process to continue with the EPC, so to build the plant. The capacity is 200 megawatt in this case. Startup is planned for 2027. And the purpose of the plant is to produce sustainable liquefied methane. So there will be also a carbon capture and a methane synthesis together with the green hydrogen plant, then producing synthetic methane, and then this will be liquefied and then transported from Finland to Germany mainly to be used in the truck as a fuel. And the second project I want to show you is from the iron and steel industry. So that Salzgitter in Germany, they have a huge transition going from the blast furnace route to the direct reduction of iron and electric arc furnace to produce green steel at the end of the day. And one piece of this transition is green hydrogen, an important one. And our scope is here to build a 100 megawatt green hydrogen plant. It's a EPC and it will start the operation in 2026. And yeah, we are in the middle of engineering at the moment. So that's the end of my presentation. As I said, Andritz is really young in this Power-to-X green hydrogen topic. However, we see a huge potential to, on the most important side, contribute to the green transition and reduce the CO2 emissions. We see the most use cases now in the industry. Others will come later, like in the mobility, and definitely we stepped in the market successfully, and we are now growing this business. Thank you very much.
Thank you very much, Peter Eisenköck. Again, other questions from the audience?
Hi, good afternoon. I'm from Regulus Consulting GmbH, and I would like to know that do you provide the solution after production regarding storage and the transportation besides the car transportation?
Do I get the question right? To store and
storage,
transport the hydrogen?
Yeah, hydrogen.
Okay. Well, for storage, compression, all that can be included in our scope. Depending on the project, the transportation would then be already some other partner that is doing it. If we take the example of this copper project in Finland, we do the green hydrogen production, we do the buffer storage of hydrogen at the level of 80 bar to have a continuous operation then of the methane synthesis, and then the liquefaction and also the transportation is already in other scope, not in ours.
Thank you. There are other questions?
Thank you very much. From company Hen, one question regarding the cooling. So you're speaking about cooling function, which optimum temperature, operation temperature need the system to be in the optimum function?
Yeah, this electrolysis, alkaline technology, and pressurized, I forgot to say. Yeah. So you also get the hydrogen pressure already out of the electrolysis system, runs at 80 degrees centigrade. So you have also from the cooling system heat available. If, for example, you have a district heating, you can also use this heat to put it into the district heating.
Do we need for that special heating, cooling equipment, or it's the environment is enough to cool that?
No, we have cooling equipment, so either we use dry coolers, which we simply put on the roof, or there is a river nearby, then we have a water cooling, or seawater if it's at the seaside. So it depends on the project, but we need a cooling media, yeah.
Thank you.
Okay, I think there was another question is still there. Otherwise, please reach out. Okay. So one last question, and yes.
Yeah, Adrian from Siemens Energy. I have a question regarding the overall rate of efficiency, for example, for the project in Finland. So what is the rate of efficiency to H2 and then further to methane for the plant?
Yeah, I mean, the efficiency is, of course, always an important discussion. And for the green hydrogen plant, we typically talk about the specific power consumption. So how many kilowatt hours of electricity do I need per cubic meter or kilogram of hydrogen? And I would say what Andritz is doing, that we are giving guarantees for the complete plant. Yeah? And I don't want actually to say the values right now, because it depends on the scope. Yeah, is there a compression included, yes or no, etc. And if you go further downstream in the copper project, taking this methane synthesis, liquefaction, and transportation, then of course you have further losses. I actually would like to hand over this question to the next speaker, which is Alexander Trattner, and I think he can give you an answer from a scientific perspective on that.
Thank you for pointing it out. Perfect. And if there are additional questions, again, please reach out to Peter Eisenköck after the session. Thank you very much for presenting. And it was already said, for our next speaker, we stay at the topic of green hydrogen, but we look on it more on a research perspective. In general, in the GREENTECH Valley, we have more than 2,000 researchers who research in the field of green tech, and so is Hycenta. And in that context, I welcome Alexandra Trattner, CEO and Research Director of Hycenta, who will today tell us something about the research on hydrogen technologies and how green hydrogen is the key to the energy transition. Thank you for being here.
So thank you for the kind introduction, ladies and gentlemen. It's nice to be here. Within the next minutes, I want to point out the working horse for the production of green hydrogen, and it perfectly fits to the presentation we've seen before, because now I want to give you a quick overview about how we can produce hydrogen by water splitting, meaning electrolysis. Some words to my organization. Hycenta stands for Hydrogen Research Center Austria. We are Austria's leading organization performing R&D in hydrogen technologies and electrochemical systems, meaning electrolyzers for water splitting, but also to work on fuel cells where we use hydrogen to produce electricity and heat out of this again. These are also potential technologies for sure for the energy sector in the future. So my group is close to 90 researchers. We are an extra university research organization at Graz University of Technology. Next year we become 20. So we're having 20 years of expertise, and we have a strong focus on experimental R&D. So we are doing more than PowerPoint investigations. We are really testing the technologies, prototyping them, and advance the technology in this regard. For the future, we see hydrogen as a key enabler. So it's part of the solution. It's not the solution itself, but it's part of the solution to transform our energy system to a greener future. And it's a big challenge we see in front of us when we are thinking about Austria. Austria has around 35% of renewable share in the overall energy system. The world has around 22% share, renewable share of the overall energy system. So this means we have to triple in Austria, or to multiply it with a factor of 5 worldwide, the renewable capacities. And this will cause significant effects and therefore we need solutions to integrate these renewable energies on a spatial and temporal basis. So it's really perfect if you can produce, if you can integrate green electricity directly out of the power source to distribute over the e-grid, to store it, for example, in the pump storage in Austria, and to bring it directly to energy, mobility, and the industry applications. But in Austria, we have 1,000 full load hours on the solar plants, we're having around 4,000 hours on the water plants, and we're having around 2,000 hours on the wind power plants. So there's a big gap between the usage of 8,760 hours in the energy, mobility, and industry sector, and on the generation side, where just a few thousand hours are available. And for this temporal and also spatial integration, we need green hydrogen technologies, mainly power to hydrogen or power to X, to integrate this energy and to produce hydrogen out of it. And green hydrogen and green electricity are the only two energy carriers we have without carbon. So these are the carbon-free energy carriers which we can use for the future. Hydrogen is not a niche today. So already today, around 10 exajoule worldwide are used for hydrogen consumption. So this is around a share of 2% of the worldwide energy system already consumes hydrogen. And this is mainly in the chemical industry, it's in the fertilizer industry for producing ammonia, but also in the petrochemical industry to produce methanol, for example. Out of this 10 exajoule, the most part of it is today produced on a fossil basis, so mainly out of steam reforming of natural gas, and just only 3 to 5% of this hydrogen consumed today is produced via electrolysis. So there's a big market potential for electrolyzers. I think it's very clear what we've also seen before in the presentation, because for sure we have to transform this fossil consumption for this fossil part, grey hydrogen to green. So we have a growing potential of a minimum factor of 20, but for sure we'll see further applications in the future. For example, new direct reduction of iron ore, building heat and power, so where we'll use the heat and the power combined in big power plants. We have to decarbonize further industrial energy and heating processes, and for sure also hydrogen will play a role in the mobility. So nobody knows how big the share will be in the future, but for sure everybody knows that we'll have a strong growth in the hydrogen sector. And to integrate all of this in the industry in the future, we have to do the R&D now. We have to improve the durability of the systems, we have to improve the degradation so that we're having longer lifetimes of the systems, and we have to improve the efficiency for all of this, and to ensure the circularity so that the catalysts and all the materials used are really integrated in a circular economy further on. Electrolysis is also not a new topic, so it's an old technology. So it's more than 200 years old that we know the process of water splitting, and already out there are big facilities, up to 400 megawatt installed already 80 years ago. So we know how to build it. And also on this picture you see the picture in the center. You see the, okay, it doesn't work very well. So one stack has around the power of 3 to 4 megawatt. It has around 2 to 3 meter diameter and is around 6 to 7 meter long. So these are the old technologies, not to say mature technologies. Yeah. But there are furthermore how we can split the water into hydrogen and oxygen. So the oldest one is to use it via an alkaline technology, where we use potassium lye, so it's an alkaline liquid, and the electrodes are consisting of simple, usually nickel electrodes. So it's a cheap material and it can be recycled very well, but it's an old technology with, let's say, a very big footprint we've seen before. For the future, we see a big benefit in the PEM technology. It's a proton conducting membrane technology. So there's a very thin membranes, so some micrometer thick plastic material, which is conducting protons, and the electrodes are consisting of platinum and iridium as a catalyst. So these are rare materials for sure, which we have to improve and recycle. But this technology can operate very flexible. So it can be integrated to renewable power sources, it can produce high purity hydrogen, and it has a very big efficiency. So for the future we see a further technology, AEM technology. It's a hybrid of the alkaline and the PEM one. Again, we can use very cheap electrodes based on nickel mainly, and in the center itself, the electrolyte is again a membrane which separates cathode and anode. So these are the low temperature technologies ranging in the area of around 70 to 75% in efficiency. And if we want to achieve highest efficiencies up to 85%, then we have to use high temperature technologies like the SOE technology, but we need excess heat. This means these are technologies which are mainly capable to connect it with industrial facilities. Every technology out of these shown has its challenges to improve them for the future. On the PEM technology side, we had a big EU project, a Horizon project, where we have done R&D on recycling of iridium, because today, with the concentrations which we are using in the PEM electrolyzer, we have to reduce it by a factor of 10 to have enough iridium worldwide available to cope with the growing sector of the PEM electrolyzer sector. We have achieved very big progress in this demand, and we also have created a recycling process for this rare material iridium, so therefore it's a path further to the circular economy. So, and for the future, we see all of these technologies to be integrated. So the workhorse for sure will be the next years the alkaline electrolysis. The racehorse is the PEM technology, so which is can be connected to these flexible renewable power connections. The foal, so the new technologies in the future, is the AEM electrolyzer. The circus horse, which can be very efficient, connected to excess heat, is the SO technology. And in progress is the second heat technology. The status, we have still a far way in front of us. Today there's 13 megawatt installed in Austria, 12 megawatt are in erection, and the plan in Austria is to have 1 gigawatt in operation in 2030. So there's a big potential for the growing market in Austria as well. So thank you, and I'm waiting for your questions.
Thank you very much. We have time for one question. Is there one question? Okay, so, but please, again, if there are some questions later, please directly ask Alexander Trattner after the session. So thank you very much. Okay, for the next presentation, we will hear something about the Green Carbon Lab and the syngas platform in Vienna. And we will hear about technologies for valorization of biogenic residues as green fuel and carbon products. For that, here is Manuel Schwabl from BEST, who will explain us what that's all about. And he is working now for 16 years at BEST with the focus on technology development. Thank you very much for being here with us today. I'm looking forward to your presentation.
Thank you so much for having me as well. It is also a very pleasure to speak after such very nice speakers beforehand. I think I have a lot of connections to all of you actually, because biorefining technologies are nowadays providing hydrogen, are nowadays providing syngas, are providing carbon products for steel industry as well for multiplication of appliers. And here today I want to show you in particular our two running horses we have in our stable at BEST. One is located here in Vienna and the other one is located in Wieselburg. But talking first about what is our vision, we BEST Bioenergy and Sustainable Technologies research technologies for exchanging fossil carbon-free bioenergy, for upgrading low-value feedstocks in order also to provide an impact on circular bioeconomy, and last but not least to leave also an impact on the climate by CO2 negative technologies. How do we do that? We do it in particular in two different dimensions. On the one hand, we always have the whole value cycle and whole value stream in our focus. So starting always from the feedstock, investigating which kind of potentials are for refining the feedstock, and identifying also in the very last end which kind of product is coming out. And in the middle, This is where our major research and development takes place. It's the conversion process, where we focus on the one hand on gasification and pyrolysis technologies, but also my colleagues in Tulln, for example, they do microbiological conversion of different biogenic waste feedstocks. And as well, we investigate different kind of downstream technologies, enhancing this product carbon and hydrogen products coming out of these conversion technologies. The second dimension we do, in every technology we investigate, we go from very, very lab scale, so investigating in milligrams, in micrograms, the conversion potentials from gasification and pyrolysis. Then we go a next step in a continuous operating system and investigate the impacts also in a laboratory scale, providing already a couple of kilograms maybe of the product. And then we have quite unique infrastructure at best for a pilot scale demonstration of the full value cycle. And here I want to show you now one of our two stallions. It is the syngas platform in Vienna. Actually, I think tomorrow there is also an excursion going to Simmering, and right next to Bioenergy, we are having this this dual fluidized bed gasification technology operating, which is a 1 megawatt system provided for various kinds of feedstock. We investigated already sewage sludge, but also pulp and paper rejects or municipal waste is possible to be gasified in this technology. And downstream we have 20-50 kilowatts Fischer-Tropsch synthesis technology also implemented, which is able to demonstrate the production of 1 barrel per day of diesel, kerosene, and waxes. And yeah, what does it provide as well? Of course, hydrogen. We have also a methanization on site and at the site itself, and have pressure swing absorption. So I want to invite you in particular, if you have an interesting feedstock, which you are thinking about of providing it to a gasification technology and producing valuable green carbon products out of it, we can test it within this 1 megawatt demonstration technologies and provide you first glance on your value cycle. The next stallion we have, and I want to stress that horse metaphors not any longer, however, we have our Green Carbon Lab in Wieselburg, actually, which focus on the investigation of pyrolysis technologies. Pyrolysis itself is also a thermochemical approach, similar like gasification, but it focuses on a broader variance of green carbon products. On the one hand, it produces solid carbon products, which is called also biochar, and this biochar has very unique properties which can be applied in different kinds of sectors. Mainly in the current times we focus on agriculture application of biochar, where biochar is utilized as a soil amendment tool in order to stabilize water conditions, erosion processes, but as well in order to buffer nutrients and nutrient runoff of the soils. We also have a project together with the steel industry, and here the colleague from Andritz was missing actually one point. When steel industry will transform once from fossil-based carbon to hydrogen, they still have big needs in carbon. More than 1% of carbon is alloyed always in the steel itself, and also this kind of carbon needs to be provided in a sustainable manner. And biochar has the potential here to provide also this carbon source to the steel industry. And at the Green Carbon Lab, in cooperation also with the first Alpine, we produced the first time in Austria also such biochars for steel industry. Likewise, we can introduce this biochar also into composite materials. I focused here on plastic composite as we have it already demonstrated, but also concrete composite possibilities are possible in order to sequester carbon for a long time period. Besides of these solid fractions, also gases and condensable fractions are released from pyrolysis technology. The gaseous fractions are normally used to produce high temperature heat and combined heat and power. But it can also be upgraded, of course, for chemicals or for syngas, even to hydrogen actually. And the technology itself is actually not very new. Pyrolysis has been done and conducted since centuries, since decades, but focusing on the products itself, not only as a source of barbecue, as a source of, it was done also for alloy making in the past, but now we focus also on the carbon itself and to sequester the carbon, to utilize the carbon and not to bring it into the atmosphere. And this is also where I want to end actually my presentation. I thank you so much for your attention. And here you see also my whole team in Wieselburg, and I would be very happy if you have a couple of questions also, and if I have time left for a couple of questions.
Thank you very much. We have time for one question.
Perfect.
So, is there one question? Otherwise, I'm sure that later on there might be many, so please reach out to Manuel Schwabl.
Thank you so much.
And then we've come to the final presentation, and the final presentation is from Sandra Viczek from Holcim. She's a production manager, and with her expertise in waste utilization and environmental sciences, she will shed light on the cement industry's journey towards achieving net zero emissions. Thank you for being here, please.
Yeah, thank you for the invitation. I'm very happy to be here today and share our journey with you. I work at Holcim. Holcim has several cement plants all over the world. And in Austria, we have a total of 2 cement plants, one in Mannersdorf am Leitergebirge in Lower Austria, and one in Retzna in southern Styria. And in total, these 2 cement plants produce about 1.6 million tons of cement every year. So why net zero? The cement industry is thinking about CO2 emissions for quite a long time already. And this has one very simple reason: we emit a lot of CO2. It is estimated that the cement industry amounts for about 6 to 8% of global CO2 emissions. So that's a huge number, but it is also a huge lever. And we want to pull that lever because that means if the cement industry reduces CO2, this really has an impact. And that's what we want to do. But first, of course, we need to understand where does our CO2 come from. There are 2 major sources in the cement industry, mainly during clinker production. So what we do in our factories is we produce clinker, and then we use that clinker with other materials in order to produce cement. And the clinker production is very energy intensive. We need a lot of fuels for it, and the combustion of these fuels leads to the emission of CO2. But that is only 1/3 of our CO2 emissions, because the other 2/3 actually originate from our raw materials. Our main raw material is limestone. So chemically speaking, it's calcium carbonate. And when we heat that to high temperatures, then we get calcium oxide, which we need for the clinker, but we also release CO2. And that's responsible for 2/3 of our CO2 emissions. So we have some opportunities to reduce our CO2 emissions. For example, we can substitute fossil fuels with alternative fuels. We can also use alternative raw materials, ideally such materials that are already decarbonized, so that don't contain carbonates anymore, but the oxides instead. We can also reduce the percentage of clinker in our cements, of course, within the framework of the standards. We can use alternative clinkers, so calcined clays are often mentioned and all these things. And of course, we can also use carbon capture and storage or utilization. Especially with the first two options, with the alternative fuels and alternative raw materials, we also tackle another problem of today's society, which is limited resources. So the cement industry is an active part of the circular economy, since most of our alternative fuels and raw materials are actually waste, and we can put them into our cement kiln and recycle them in there. And especially in the field of refuse-derived fuels, we already have a very long tradition in Reznay cement plant where I work. We are usually using 100% of alternative fuels and no fossil fuels at all. I just checked 10 minutes ago, we run with 100% as planned. We are here on top of the list with 98% because we have to use fossil fuels during our startup and shutdown of the kiln. So on a yearly average, we reach 98%. But as you can see here, this is not only a topic in Austria. There are several other cement plants in Europe which already use high amounts of alternative fuels instead of the normal fossil fuels. We have co-processed about 3 million tons of refuse-derived fuels in 2023 in Europe. And one thing that is special about using these fuels in the cement industry is that we do not just recover the energy, but we actually have a mixed recovery. On the one hand, yes, we use the energy, but we also use the ashes that are formed in the combustion process, because they actually contain valuable raw materials for our clinker, and they are incorporated into our product. So we do have some part of recycling as well. And at the moment, there's actually a standard being elaborated, which should be published by the end of this year, I guess, which determines how to exactly calculate these shares. So we were very successful with the fuels already, and now we want to go the same path also for the alternative raw materials. We use quite a lot of different alternative raw materials already in our cement plants here in Austria. For our clinker, we have about 30% of these alternative raw materials in use already. If we have a look at cement, the share of recycled material is even higher because we can use additional materials such as construction and demolition waste that we have already heard about today. And one cement that we produce in Reznay is called EcoPlanet RC, and it consists of 50% recycled material already. So despite all these efforts on the material side, we are of course realistic, and we know that we will not reach zero CO2 emissions just by exchanging some materials. So we also want to use carbon capture and storage or utilization techniques. There are about 50 projects planned in Holcim plants all over the world, and one of them is planned in Mannersdorf. It's called C2PET. And what we want to achieve with this is we want to make CO2, which is problematic at the moment, a resource for the future that can be used in a circular economy in other industries and can be made into products again. So we are quite confident that with a combination of all these approaches, we're going to reach our target of net zero. And yeah, thank you for your attention. If you have any questions, I'm happy to answer them.